Perfect. So the project that I've been working on together with Jose for the incubator program is about patterns of COVID-related mis and disinformation on Twitter. So we were looking to detect themes of mis and disinformation in our data, and we also wanted to work on data visualizations for the broader patterns for the bigger research project. So to give you some background, this is part of a larger NSF study, and it's a collaboration between the University of Washington and Louisiana State University. And this overarching research looks at COVID-related mis and disinformation on Twitter during the first two stages of surges of COVID infections in Washington State and in Louisiana State. And the project focuses on Twitter users' sentiment and language use. So on the UW side, I've been working with Dr. Sarah Curran of the Center for Studies in Demography and Ecology, and Dr. Jessica Beyer from the Cybersecurity Initiative, and we have a team of 4 undergrads as well. So the UW side, we're providing social science expertise, and on the LSU side, they're the computer science experts. So with the incubator, I wanted to try and bridge this gap between the two teams. And as the RA for this project, I wanted to improve my understanding of the tools that were being used, the data science tools. And I wanted to also use some myself, and that with the goal of improving our collaboration in the long run. So we've actually been working on 6 different papers. We have one that's on credibility and bias of COVID-related news that's shared on Twitter. We have another one on demographic and political identity and attitudes towards COVID. There's another one on Twitter influencers and public health discourse. Another one is on themes of COVID-related misinformation. So that's the one that we were focusing on for this project. There's another one on patterns of sentiment and language use before the first surge. And lastly, we have one on public health messaging. So our data are a 50% sample of all tweets from users located in Washington and in Louisiana before and during the first and second surges in COVID infections in each state. So that's from the 23rd of February to the 30th of April 2020. And then the second surge is the 15th of June to the 15th of August 2020. And our sample consists of all tweets, including those not related to COVID. And we've then filtered them using COVID-related keywords. And that then allows us to contrast COVID-related discussions on Twitter with overall patterns of engagement. And we have over 100 million tweets, so it's quite a lot to come through. So using some data science tools are really necessary here. So I'm going to start off by talking about the detection of, oh, sorry, I have this slide first. So for the incubator program, first we wanted to work on misinformation detection. So we wanted to match the pointer database of misinforming claims with misinformation in our sample using Engram Analysis. So the pointer database is an open it's an open database that you can access online, and it's crowdsourced. So it's fact checkers from around the world that are contributing to this database. And so we were focusing specifically on the dates from our that we were interested in, and also, of course, claims that are in the US. And we also wanted to detect themes of misinformation in our sample. And then the other goal that we had was to visualize our data. So we wanted to have a tool that first we could use internally for both the UW team and the LSU team, so that we could look at some of the broader patterns in our data. And because we have so many different elements that we can consider, we wanted to visualize comparisons between Washington and Louisiana state, also between the first 2 surges of the pandemic. We also wanted to look at comparisons between different stages of each surge and comparisons between different populations, because we have age and gender of users. We've been using M3 to infer that. So as I said, we scraped the claims from the pointer database for the first surge and the second surge, and that gave us a total of 827 claims. So if you look at the pointer database, this is what it looks like. And we started scraping them and we realized that the ratings for the claims, they weren't consistent. So here, for example, you can see one that's rated as misleading. Here you have one that's rated as partially false. And of course, we wanted to have a clearer and more consistent way of considering all of these claims. So we started looking at fact-checking literature and Pointer more specifically to try and figure out how we were going to treat these claims, because we didn't want to go back and fact-check ourselves. So we thought we found this paper, and these authors, they looked at PolitiFact's fact-checking, and PolitiFact is actually owned by Pointer. So quite a few of the claims in the Pointer database are from PolitiFact. So these authors examined a random sample of 858 claims that were fact-checked by PolitiFact, and they used 24 criteria. They based this on fact-checking literature and also the International Fact-Checking Network's Code of Principles. And they found that several claims weren't checkable. For them, 33% of their sample wasn't checkable because claims contained complex propositions. So although a claim was treated as one single claim, there are actually multiple claims within it with varying veracity. So that's what leads to the kinds of ratings like partially false, partially true, and mixed. They also found that 11% of their sample wasn't fact-checkable because the claims were ambiguous. Maybe they reflected the opinion of the speaker or made projections about the future. So we decided that we wanted to use this paper to eliminate non-checkable claims in our sample. So together with another coder, it's one of the undergrads who was working for us, Priya Sarma. First, we eliminated claims that were rated as half true, misleading, partially false, partially true, and mixed. And that left us with 684 claims. And then together we manually checked the remaining claims. We did half each for statements that were too ambiguous, that made projections about the future, that reflected the speaker's personal opinion, or that reflected the speaker's personal experience. And then we checked each other's elimination of these claims. And that left us with 676 claims. And as we were going through it, we also realized that there were 2 claims that actually weren't COVID related, and there was one that wasn't misinforming. So we removed those and we were left with 673 claims. Then we wanted to establish the themes. And so we wanted to do this manually for the Pointer database claims. And then we wanted to apply those themes that we were finding in the Pointer database to our Twitter sample. So the first step was open coding, which is a social science term. It means that we were going in there without any preconceived categories with the goal of first establishing those categories. So it's kind of a loose creation of categories. So each of us did half of the sample and we established these preliminary theme categories and we started writing how we would define them. Then for the second step, we both labeled the same random sample of 50 claims using these preliminary definitions. And we had a notes column where we could suggest new categories. And then we went back and together we compared the labels that we had created and we discussed any claims where we disagreed, and then we expanded and amended our theme definitions accordingly. It goes from step 2 to step 4, but this is step 3. Then each of us labeled half of the sample and we, using these definitions that we had created, and we flagged any claims that were difficult to categorize. Then again, we consulted each other, we discussed all of the flagged claims and we either amended them or we left them blank. And in the end, we had 25 claims that we left blank. They didn't correspond to any of the theme categories that we had created, and we thought there were too few to create new theme categories. So that left us with these themes. So we have a vaccine theme, which relates to both the COVID vaccine and the flu vaccine and others. We have a cures category, which looks at cures and preventative measures. We have a medical supplies category that looks at PPE, hand sanitizer, mask wearing, and ventilators. There's also a false attribution category, and this was actually the trickiest category. It's claims that were falsely attributed to a public figure or where photos or videos are falsely described. So for example, there was one, I think it was showing a beach and saying that beaches were packed at the height of the pandemic, but actually the photo was of a beach in Brazil in 2013. So for these claims, we actually had to go back to the fact-checking source to make sure that it was actually false attribution. Then we have a very broad category of conspiracy. So we went by the definition of conspiracy as a secret plan by a group to do something unlawful or harmful. And that includes claims that relate to or allude to theories about Bill Gates' involvement in the pandemic, the virus being a hoax, the deep state, microchipping, virus origin stories, intentional spreading of the virus, and 5G. Then we have a virus downplaying theme. So that's claims that downplay the severity of the virus, including that states have false infection rates or death counts, claims that some groups aren't affected by the virus, or claims that COVID is similar to the flu, or that herd immunity had already been reached back then in 2020. There also is a COVID testing theme. So we found quite a few, especially early in the pandemic, saying that testing for COVID is dangerous. We have a government COVID funds category that looks at emergency funding and stimulus checks. There's also a government intervention category. So that's about government restrictions designed to contain the virus, like social distancing and lockdown, and also government censorship. We also have a virus transmission category. So that includes animal to human transmission, objects that carry the virus. And this isn't about transmission prevention, that falls under the cures and prevention category. Then next we have a category about the virus trajectory abroad. So especially at that stage of the pandemic, it was talking about Italy quite a lot. We also have an other outbreaks category. So here it's comparing the progression of COVID with other outbreaks like Ebola. There's a Congress category that looks at Congress and members of Congress. It's also a celebrities with COVID category and a health authority category. So that's claims related to health authority figures like the CDC, Fauci, and the WHO. And these tended to be about government guidelines, so they don't fall under the government intervention category. There's also an economy category that looks at job losses, how businesses adapt to the pandemic or how they're affected by it, the national economy more broadly, and also the stock market. And lastly, we have an exaggeration category. So it's claims that inflate infection and death counts, hospitalization rates, and transmission rates. So then once we had done this manual portion, then we wanted to do the Engram analysis. So for those of you who don't know, Engram is the sequence of N words taken from any text document. So you have unigrams, bigrams, trigrams, and probably also Ngrams for 4 words. I don't know what that's called. So if you take, for example, the phrase coronavirus is contagious, if you're looking at unigrams, you'd have coronavirus is and contagious. If you're looking at bigrams, there would be coronavirus is and then is contagious. And for trigrams, it will be the entirety of the phrase coronavirus is contagious. So the goal with the Engram analysis is to find the Ngrams that are weighted in regards to the theme in its totality. So you're looking at all of the claims under a theme and looking at which Ngrams appear the most. And you're matching those Ngrams in the pointer database with the Ngrams in our tweet sample. And then that would allow us to detect misinforming tweets. So here we have a pointer claim, and it's about coronavirus being linked to the 5G rollout. And this claim falls under the conspiracy theme. So actually we found that the top unigram under the conspiracy theme is 5G. So we can use that to infer that this tweet, this isn't actually from our sample, it's just an example I found. We can use that to infer that this tweet is likely misinforming. And here we're using unigrams and bigrams for our work because tweets are so short that we found that trigrams aren't that useful. So the first step is to clean the claims. So we removed special characters and stop words, and we replaced all numbers with count because otherwise numbers appeared as Ngrams. and we made all the words lowercase. And then using the TF-IDF method, which is term frequency inverse document frequency, we first vectorized each word and each combination of words, we vectorized each word. So each word is converted into a numerical representation. And so we do that for each word, we do that for each combination of words. And then these words are weighted based on the words in the other claims that fall under each theme, and each word is assigned a weight, and the TF-IDF adds up to 1 in total. So I can show you here. These are some of the categories, and these are the top 25 features that occur for each category. So as you can see, there's still a little bit of cleaning up that we need to do. We also need to work on the theme categories more. I think we need to condense them more and consolidate them a bit. And then we can start matching that to our tweet content. But so far, these are the top features that occur in the claims in the pointer database. So we haven't yet applied this to the tweet sample. But yeah, here you can see for some of our top themes, the features that are occurring. And later on, we plan to use SPERT. But first, yeah, this is where we got up to with the incubator in our 10 weeks. And the second part of what we have been doing in the incubator is the data visualizations part. So we wanted to create a dashboard using the Shiny package in R. So I can actually show you in the Shiny app structure, it has 3 components. So there's a user interface object, and this controls the layout and the appearance of the app. Then here there's also, so you can see, then there's also the server function, and this contains the instructions that the computer needs to build the app. So it's code for the plots, which is here. And then lastly, under global here, it's a call to the Shiny app function, and it creates Shiny app objects from an explicit user interface server pair. So that's this tab here. So I can show you what the dashboard looks like. So that the first tab here, so we still need to add titles and clean it up a bit, but this is for Washington and this is for Louisiana. And you can see here, you can choose the indicators. So first here we have COVID. So this is for COVID related content is in orange here, and non-COVID related content is here. And this is looking at sentiment patterns for both types of content. And sentiment goes from -1, which is negative sentiment, to +1, which is positive sentiment. And we used Vader to infer sentiment from our tweet content. And so here, this is for the first surge, but we can also choose for the second surge. And a little bit slow. My internet isn't so great here. And we can also look at age groups. So we have in blue here users that are over 40. In orange here we have users that are under 40. And we can also look at gender here. So it's, yeah, not a very clear distinction in Washington, but in Louisiana, there's a clearer distinction for the second surge. So this is the first page. And for the second page, we're looking at maps, state comparisons. So here, again, we can choose the indicators. So for example, for women, we can see how much they're tweeting in each state by county. And again, you can choose first surge or second surge. And again, you have age as well, and COVID or non-COVID related content. And also there's the option to look at sentiment or tweet counts. And then here with this button, we can see a sample of the tweets appearing in each state. So I can't actually show you that because with our agreement with Twitter, we can't show tweet content publicly. but this is a reactive part of the dashboard. So it pulls from 100,000 random tweets from our sample each time. Every time it runs, it's a new sample. So that makes it more efficient than if we were actually drawing from the totality of like our 100 million plus tweets. And yeah, it's reactive, so it only runs when you press the see data button, and that again makes it more efficient. And you can also, there's an option to search within that random sample. So yeah, I think if we make the dashboard public, which we hope to do later on, we'll probably choose tweets from public figures so that we don't have to worry about the agreement with Twitter. And then lastly, the last tab here is, as I showed you, it shows some of the TF-IDF comparisons. Later on, we hope to update that to look at the results from BERT as well. And yeah, generally, we want to use this tool together with the team at LSU. It would be great to link this on our future publications and just progressively add more and more. But yeah, for now, I think it's in great shape for our internal use. And yeah, that's what I've been doing with Jose during the incubator. Thank you.